Welcome to BrazilJS and our talk, Making Music on the Web. My name is Ben Morse. I'm a developer advocate and product manager at Google, where my job is to help make the web better for users and for developers alike. I'll be joined today by my colleague Max Vogler, who'll be appearing about halfway through this talk. So BrazilJS, I love BrazilJS. I'm sorry I couldn't be there in person this year. I'm now, instead of in beautiful Porto Alegre, in beautiful New Jersey over here. Porto Alegre, I miss it. I miss the city. I miss the people. I miss the sunshine, the food, the mall with its Outback Steakhouse. I miss all those things. And actually, I have been there in person. I can prove it because here I am in front of the very same sign. And perhaps maybe the worst selfie anyone's taken ever throughout the existence of the selfie, the worst hair day ever. My skin looks terrible. And there you see my finger there in the corner of the page. So perhaps further proof that I was there, I'm wearing the same shirt today. Here it is, BrazilJS. Anyway, let's go from this nerdy picture over here to a different nerdy picture, which is more relevant for our topic for today, making music on the web. In the beginning, the web was an amazing place, but a simpler place. It really was there. It was really for documents. It was a document description language, and you could make HTML, which defined a document. You could have text in there. You could have basic formatting, H1s, H2s, underlining. But the cool thing was hyperlinks. You could link from your document to a document somewhere else on a server across the world. And users could travel there from website to website across the world. It was kind of neat. But basically, it was for content. Later, we got more advanced features like images and perhaps even CSS. And by the late 90s, you could visit your local newspaper online and discover that gasoline prices were rising by 5%. And there were cool animated GIFs, like the GIFs there on the left side. That was all pretty good. And then in the early 2000s, things began to change again with the invention and discovery of Ajax. And you started to see on the web applications that previously had been possible only on native applications, but now were possible to get through a website. Like Gmail, for example. Gmail was not as well designed, perhaps. Well, maybe not. That's not really fair. Gmail didn't look quite as fancy as native applications because it was a website. And it wasn't quite as sophisticated in terms of functionality, and it involved some latency in terms of downloading messages from the web and sending things instead of buffering them all and sending them later on. And yet it became very popular pretty quickly. So why is that? Although Gmail was not as sophisticated as native alternatives, it had some web advantages to it. Because it was on the web, you can go to a computer anywhere in the world that had a browser and use Gmail there. You could log in and see your mail anywhere, not just on your own computer, anywhere you wanted to. And there's no installation of software. You didn't have to go to a store and buy some software and get yourself home and install it. It was there for you immediately. You could link to email messages, all kinds of things like that. So the web has certain powers built in that made applications on the web already more powerful. Also, of course, it was free. And the free thing still persists today. When you use applications on the web, there normally is a free version you can get to before paying something. Kind of like phone apps often have this too. And indeed, we're seeing today creative applications appearing on the web, visual creative applications. Like on the left over here, the Gravit Designer, PWA. People love that it works across different platforms. Again, no installability, and it permits online collaboration and an amazing web feature. Clipchamp there on your right is a video editor, which I believe has at least 17 million users. There also are applications like Figma for design. Adobe offers Adobe Spark for online photo editing. And Adobe Spark, again, is not Adobe Photoshop. It has fewer features, but it's there on the web. You can use it immediately. You can share with people. It has those web powers again. Really, these applications offer the features most people need to more people than could actually go out there and buy the native applications. So there are advantages. And now we're also seeing a lot of really nice music creation applications out there, thanks to the Web Audio API. Notice this is not new though. This page is from HTML5 Rocks. It's from 2011, about 10 years ago exactly. And it explains this pretty clearly. Actually, MDN puts it really nicely, I think. Just as the image element is to canvas, so the audio element is to Web Audio API. So image elements let you display an image, load an image, and display it with some formatting on your web page. Canvas lets you actually modify images and create them and make arbitrary graphics on the web page. This is similar. With the audio element in HTML5, you can play back audio from a file on a server. With Web Audio API, you can modify audio and make new audio. So you can make sounds and music of whatever kind you can dream of. A different approach you can use is WebAssembly plus audio worklets. So just as a worker lets you run JavaScript in its own thread, audio worklet lets you run JavaScript in a special audio processing thread, which is useful for low-level audio processing lots of numbers and modifying things, which is how effects get created and mixing happens. And it runs in its own thread, so the browser can interrupt it. And you might have like audio glitches or bits of silence, which might sound really disturbing. It runs in its own thread, undisturbed. Because it involves a lot of number crunching, it's often good to use WebAssembly instead. And in fact, people have been using this who make native applications because they realized they could take their C++ and they could port it via tools like Inscriptin over to WebAssembly, and then they could port a version of their native applications to the web, which is kind of neat. And we'll see that in a minute. And also in a few minutes, Max will be talking about how to do this yourself with Web Audio API. But first, some fun demos. So Ableton, the makers of Ableton Live, the popular music creation and live performance application, there's some nice educational apps over here. Here we can just add in some drums, a little bass. We can change the bass line to the next measure. We can turn off the drums and add chords. You can see how this is useful as an educational tool. If you're not just being used in school, it's pretty helpful. Let's turn these things off. And now they're off. Another nice site to visit is the Chrome Music Lab. It's full of fun demos of different sorts, including oscillators, some of the basic building blocks of electronic music. Here's a square wave, it looks like. Ooh. We can make it get higher and lower. We can jump around. We can listen to other kinds of basic waveforms, a sawtooth. Very buzzy, isn't it? Is there a sine wave? A triangle. Ooh, very nice. So this is fun over here. And more sophisticated demos are available over here. This is other kinds of stuff. Here's a Google Doodle that came out recently for hip hop. Let's just play this here. We're gonna see a video.
Hey, what's up, y'all? It's Fab Five Freddy, direct from New.
Skip this video.
Now this is the crossfade. This is used to mix the beats. You drag it all the way to the right. Now drag it all the way to the left. Cool. Now you're doing it. Let's find a new track to play.
Skip the tutorial. We do a little scratching. I'm pretty good, aren't I? Change the record. All this is pretty impressive stuff. All here on the web. Let's close this page. Okay. Anyway, so try these things out. Also, try out some of these online digital audio workstations. BandLab is quite nice. It looks like this over here. We can play back our tracks. You see here some nice music creation stuff. We can also play tracks. We can modify things. We can mute one track, solo a track. You could record new things. You can process audio. All very nice. I think that BandLab now has at least 30 million users, and it involves online collaboration, online communities. Again, those kinds of powers the web just comes with because it's the web. Soundtrap also is a quite nice example, and there are more. I'm showing you two of these things because time is limited. Soundtrap is now owned by Spotify. Here's a nice little song over here. And again, we can modify this in simple ways or complicated ways. We can solo the drums. There they are. You can record new things. One cool thing about Soundtrap is online collaboration. You can do online chat here, actually inside the project. You can also do video chat inside the project. So it's kind of like a Google Docs situation. People can add tracks, modify tracks, and you can discuss it as you're doing it here. So These days, pop music often is made this way. Somebody makes a beat somewhere, someone else goes and adds maybe more drums or other instruments to it, and these people will do these things, upload it to the web, Dropbox or some sort of marketplace. Someone else downloads it again, adds some vocals, uploads it again somewhere else. A producer downloads all the files. Instead of doing all of that, this can all occur collaboratively within a single project. And again, most top 40 music is made in just this way. And these applications here, while they're not as complicated as Pro Tools or Cubase or native DAWs, they're quite capable, good enough for most people's purposes. And again, they're on the web. So there's that. So again, these things aren't as sophisticated, but come with these powers the web has. Things are discoverable. You can put things on the web. People can find them either by search or within the applications themselves. They're shareable. You can share projects by URL with people. Very useful. And they involve communities. People can get together and all create music in the same online applications, and they can share things. And of course, most importantly, people can collaborate because, again, they're on the web. So, okay, here's some cool demos, but how do you do these things yourselves? If you want to create your own web audio API-based application, how would you do it? For that, I bring you the one, the only, the amazing Max Vogler.
All right, thanks, Ben. My name is Max. I'm a software engineer, also at Google. My main job is to build Google's digital forensics platform that involves a lot of JavaScript and TypeScript and web stuff as well. And as my 20% project, I work with Chrome Web Audio. I build web audio dev tools and also a lot of educational examples, which you're going to see too. In the next 15 minutes, I'll give you a quick hands-on intro to the web audio nodes and the web audio platform. We're going to build a piano and a drum sequencer on the web. So let's dive into some code. First, as a sort of hello world example, let's break the silence with a very, very simple beeping sound. So to do anything with web audio, we need an audio context. This is the entry point. An audio context defines a graph of audio nodes, and you can connect them to each other freely. And ultimately, we connect them to the context destination, which means whatever the node's output will be played by the computer speakers or the connected headphones. The node that we initialize here is an oscillator node. As you can see on the right, in the default configuration, it emits a sine wave. And we say, oh, we want to have 440 hertz, which is in the audible spectrum. And this sine wave sounds like a beep, basically. Now, that's a start, but it's not really interactive yet. So let's leverage cool features of the web platform. And I think this is like one of the greatest things of making audio on the web. You get this interactivity almost for free. So in the same HTML document where we define our oscillator node, we can just add a button and listen to events. Now we say, oh, on every mouse down, we initialize this oscillator node and start it. And on every mouse up, we stop it. Now you might notice that we don't reuse this. Instead, we always create a new one if we click on the button again. And this is because once you stop the oscillator node, you cannot restart it. So that's an invariant of audio nodes and forces us to create a new one every time. That's not a problem though. The garbage collector, once this node is stopped, collects it in the background. And yeah, no resource problem here. We can create and dispose them quicker than the user could click on the button. And so let's dive in and see what this sounds like. Now, below the button, you see an oscilloscope. There you see the sine wave that is being played. Now, typically, depending on the recording frequency and your playback frequency, this wave might appear moving left to right or right to left. Doesn't really matter. All right, so that's a start. Now, let's turn this one button into a whole piano keyboard. For this, we could render just like dozens and dozens of buttons ourselves and attach listeners and give each button an ID, but there's a library for prototyping musical UIs that does this for us called Nexus UI. Now we just use a container element, could be any type, assign it the ID piano, which we can query here, say, oh, please fill it with this piano input. Now, similar to how we listened on mouse down and up, this piano gives us a state that is true when a key is pressed and false once it's released. So we can listen to the state, have a conditional if here. We say, oh, when the user presses a button, we'll create a new oscillator node as we have done before. And once it's released, well, we stop it. One added thing here is that piano input gives us the note as an integer in the MIDI notation. So this, for example, means the note 24 would be a very, very low C note. And we need to convert this to a frequency that we can then synthesize with the oscillator node. And for this, we use this piece of math here. Now, let's look what this looks like. Okay, we have a keyboard now on screen, and we can press buttons. We see the lower the button, also the bigger is the sine wave. And also when we switch from one to another, quickly we hear this crackling sound. It doesn't really sound like a piano yet, but it looks like one. So that's a start. All right, next up, before we make it sound better and remove this crackling, let's introduce some abstraction. All the audio nodes that the browser provides you, they all conform to a similar interface where there's a constructor where you put in the audio context and some parameters, and then you can call connect to a destination node. You can call start and stop. You can also put in timestamps when you want to start and stop. We'll get to that later. Now we're creating our own vanilla JavaScript class. It looks like an audio node. And inside of this, what we call a piano node is whatever we need to put in to make it sound more like a piano. So we'll abstract it away. And this will be an oscillator node and a gain node. So oscillator emits a sine wave, and then the gain node makes it more silent. It reduces here in our configuration, setting gain 0.5, the amplitude to half. So this will make it sound more silent. All right. This abstraction that we introduced, we're now using to play a more realistic piano sound. So in the constructor, we're not only putting in the note that we want to play, but also periodic wave. This is something that upfront we load from a JSON file, decode, and then put in the audio node. Now, this is the waveform that we want to play, and this is stored in the JSON file. Now, the idea is the sine wave sounds very synthetic, but we want to sound like more like a piano. So what we're doing, we're loading this JSON file, which is basically a recording that somebody did of a piano, and it's a simplified representation of how the waveform of a piano can look like. So we load this up, decode it, and this periodic wave we then play. So no longer a plain sine wave, but we're playing a custom wave. And this sounds like this. You see the waveform in the oscilloscope looks a lot more complex now. But there's still crackling, and also it sounds pretty synthetic, sounds like a robot voice. So to smoothen the sound and to avoid these crackles, we'll introduce attack, decay, sustain, and release. That's very common when synthesizing music or when playing music. Attack is the time after you press down the piano key. So from the moment of press, which is second 0, to the first 100th of a second, so that's 10 milliseconds, we're ramping up from 0 to half the possible volume. And then while the user still holds down the piano key, this volume decays by itself to 10% of the maximum possible. So we're using, this is a very simplified chart here. And in the code, we're using an exponential attack and decay. That sounds more natural because the decibels of the sound loudness that you perceive, it's a logarithmic scale. And so using an exponential ramp up, that sounds natural, but this linear representation looks natural, which is why we have it on the slides. While the user holds down the key, this sustained volume of 10% is continued, and then ultimately when they release it, it fades to 0. Well, it fails almost to 0 because this is an exponential function. We cannot ramp to 0, so we have to choose a value that is very, very, very close, but not exactly 0. It's like division by 0. It doesn't work. Now, before we go to playing samples, let's listen to the final piano. Now you hear, this sounds already a lot smoother. This is because of it plays the same waveform, but with attack, decay, and sustain. Also, there are no crackles if you play it quick. And this is because, let me jump back a slide, these crackles come from if you interrupt playing the sample while this waveform is not at 0, the sample is suddenly stopped. And this then sounds like a crackle. But by always fading down to 0 in a smooth way, we avoid this. And it sounds really natural. Might not sound exactly like an organic piano, but it also doesn't sound like a robot anymore. So that's a win. All right. Now, we said we're going to build a piano and a drum sequencer. So to play some drums, we're not going to synthesize these ourselves. Instead, somebody recorded them into WAV files that you can play back with the music player on your computer. We're going to load them from the web, and we're going to decode them with the audio context. Once decoded, we have this function play where we can put in the index of the instrument that we want to play. So we have kick drum, snare drum, hi-hat, and 3 toms. And this will then put this sample in the buffer of an audio buffer source node and play it immediately. This is playing it once, but it's not really rhythmic yet. So how could we make it rhythmic like a drum track? Well, first we think about how many beats per minute do we want to play. Let's say 90, that's a good speed. And also, how many notes per bar essentially do we want to play? So we have this pre-existing code from the previous slide to play a single drum, and then we can set an interval at like a certain delay in milliseconds. And every time this interval is triggered, we want to play the index 0, which is the drum loop. So how do we arrive at this number? Interval is set in JavaScript in milliseconds, so we have 1,000 milliseconds in a second. And then we calculate the beats per minute divided by 60 seconds in a minute. So this is beats per second, and then notes per beat. So which is 4. This ultimately, in a 4/4, like a 4 to the floor beat, is a natural sounding drum rhythm. But ideally, we would have this interactively, like with a piano. So let's look at how we can sequence drums. We're going to reuse the Nexus UI library, adding just an empty container element sequencer. We say, oh yeah, we want to have a sequencer here. Now, sequencer, if you're unfamiliar, is a grid. And in this grid, we have one row for each instrument that we want to sequence. So we have 6 samples, 6 instruments. Now the bottom row would be kick drum, snare drum, hi-hat, and 3 rows of toms. And then the sequencer, with the interval that we configure here in the start method, which is exactly like set interval, it moves from left to right, and once it reaches the right, it jumps over back to the beginning. You see this column is highlighted. This means at this step in time, every cell that is filled, the corresponding instrument is played. So at this point in time, we have a kick drum and a hi-hat that is played at the same time. How we do this in the code is every time the sequencer jumps to the next time step, when this interval is triggered, it calls the callback function step and provides an array of values. We iterate over these values. These are simple Booleans and indicate true or false if the instrument should be played at the current point in time. We also add the instrument index to this iteration, and then just if the current instrument is enabled at the current point in time, we play it with the previous code. And this looks like this, so we already see it moving, and we can add some hi-hat, some kick drum, some snare, and maybe a small drum loop of toms. And this is how we sequence a drum, and it's only like 10 lines of code, very simple. All right, this was the piano example and the drum example. As you can see, it's very easy to build this. We didn't spend too much time on the UI because I'm sure everybody at this conference knows very well how they would like to build a UI. So we skipped this out and we focused on the AudioNote stuff. And it's a nice property of the web platform. Like, you can build these things very, very, very quickly. And now to see what you can actually build with it more, there's a lot of pre-configured nodes that you can use in JavaScript. So we showed, for example, the oscillator node and the gain node. There's really cool spatial effects like stereo panner node, where you can split your stereo channels and then can move sounds around in space. That's very cool, for example, for a VR application. There are typical musical effects like a delay node. There's an analyzer node, which renders this oscilloscope that we showed. And if this doesn't fit what you want to do, if you want to do your own thing, there is AudioWorkloadNote. So AudioWorkloadNote allows you to write your own processor that operates on the raw musical frames. It's like raw bytes coming in. You can mathematically do whatever you would like to do, and you write it into an output buffer, and this is then played back. And now, a really, really cool thing is that a lot of the pre-existing musical software or musical effects or plugins are written in C or in C++, and using WASM, you can cross-compile it, the C and the C++, to WASM, load it up in the browser, connect it to AudioWorkload processor, and use all the existing musical C and C++ code that is out there. That's something really, really, really nice. And with this, I'll hand it back to Ben.
Thanks for all that, Max. So if you want to try this code out for yourself, or fork this and modify the code, or see other code for other cool demos, check out the GitHub repo at bit.ly/web-audio-samples. Give these things a try. And for a good refresher on web audio and MDN, visit bit.ly/web-audio-wow. Check these things out, play around, try them. It's fun, it's easy, and thanks for being here. You can find me at my website there, on Twitter at Ben Morse, or also on GitHub at Morse with 5 S's. You can find Max there at his website, or on GitHub at Max-Vogler. Thank you so much. Thanks for having us here at BrazilJS, and have a great day.